My friends, you are already concerned with present-day income inequality. As the Pareto distribution will illustrate, this income inequality will only grow more extreme. On the surface, you think you understand everything that this inequality spells for your future. Contrasting qualities in food, water, transportation, education, housing, safety, and more. Unfortunately, all of this is merely the tip of the iceberg. There are scientific advancements exponentially progressing as you watch this video right now, one of the most notable of which is genetic engineering. Already, single gene mutations related to diabetes, cancer, Alzheimer's, and so much more can already be identified. Hence, parents having children through IVF may want to alter the germline of their future children, perhaps to eliminate an awful Mendelian disorder, make them immune to numerous deadly viruses, make them less likely to face cognitive decline as they grow older, or even benefit from positive single gene mutations that confirm a special advantage, such as extra strong bones. Of course, the first questions parents will ask is gene editing currently safe? The answer is no. And while it will be in the future, even now, an optimal future for one's offspring can still be reached without any gene editing required. All that is needed is the law of probability. Currently, one can make selections from several or more of their embryos at a time. The selection is made following a pre-implantation genetic diagnosis. With current technology, this makes avoiding numerous single gene mutations very realistic. Hence, many do opt for this for around $20,000 in total. So, even where we are at now, some inequality is already present. Many people simply cannot afford this luxury to conceive a child through a process which will screen for these single gene mutations. But this is just scratching the surface of the polarizing inequality which the future truly holds, for it will soon go far beyond just your health. First, as more and more people have their DNA sequenced, more and more multi-gene patterns will become probabilistically identifiable. Just as you have seen the rapid exponential progress with large language models, such as the popular GPT-4 model or ChatGPT by OpenAI, this same pattern recognition goes far beyond the scope of just language. Stephen Wolfram from Wolfram Alpha gives an incredible explanation on the Lex Fridman podcast in layman's terms regarding how these large language models work, but more importantly, how patterns can be recognized that even we struggle to recognize.
Aristotle stopped too quickly, and there was more that you could have lifted out of language as formal structures. And I think there's, in a sense, we've captured some of that in some of what is in language. There's a lot of kind of little calculi, little algebras of what you can say, what language talks about. I mean, whether it's, I don't know, if you say, I go from place A to place B to place C, then I know I've gone from place A to place C. If A is a friend of B and B is a friend of C, it doesn't necessarily follow that A is a friend of C. These are things that are, if you go from place A to place B to place C, it doesn't matter how you went. Like logic, it doesn't matter whether you flew there, walked there, swam there, whatever. This transitivity of where you go is still valid. And there are many kinds of features, I think, of the way the world works that are captured in these aspects of language, so to speak. And I think what ChatGPT effectively has found, just like it discovered logic, people are really surprised it can do these logical inferences. It discovered logic the same way Aristotle discovered logic, by looking at a lot of sentences effectively and noticing the patterns in those sentences.
But it feels like it's discovering something much more complicated than logic. So this kind of semantic grammar, I think you wrote about this, maybe we can call it the laws of language, I believe you call, or which I like, the laws of thought.
Yes. That was the title that George Boole had for his Boolean algebra back in 1830, but yes.
Laws of thought?
Consequently, if these large language models can identify patterns in language, this is certainly transferable to any medium. Of course, this means it can apply to genetic patterns as well. patterns that we do not have the ability to identify can be identified by these models, given a sufficient amount of data. In other words, when enough people have their DNA sequenced, these models will soon begin to identify more and more of these multi-gene patterns, whether they involve hair color, eye color, or even probabilistic height, which is comprised of tens of thousands of genes. These models are already here. We simply need more data, which will inevitably come with time. Even OpenAI themselves, including Sam Altman and Ilya Sutskever, are warning of the risks involved with synthetic biology and more, because this pattern recognition goes far beyond just language. It should be clear that no matter how complex the human genome is, with sufficient data, these multi-gene patterns will become probabilistically identifiable. Currently, about 30 million people have had their genome sequenced, compared to there being over 8 billion people alive. As Charlie Munger said, "Show me the incentive and I will show you the result." As soon as more profitable opportunities arise within genome sequencing, incentives will be provided to people to have their genome sequenced. Consequently, this will lead to exponentially more data for these models to analyze for more pattern. Okay, so let's say hypothetically, we come to a point where you can identify these multi-gene patterns. You're still limited to just selecting from a few embryos you have, which might be 5 or 6 of them, right? Certainly, there can't be anything too drastically unique in that mix. Absolutely agreed. But what if you had around 1 million options to choose from? And you had the data for each of these options very clear in front of you. So clear to where you could view them on a dashboard, and even filter for certain criteria, as if you were creating an avatar. Out of 1 million possibilities, there is an extremely high chance you are going to find an option that is precisely what you are looking for. Even if it is not common for you and your partner to have a blue-eyed child, for example, with 1 million options, the law of probability would suggest that it is more than just possible for a mutation to occur with at least one of them. And it goes even far beyond just physical appearances. Even IQ and personality traits are probabilistically deterministic, meaning the environment does indeed have an influence, but your genes still play a massive role in them. These multi-gene patterns, while extremely complex, will soon be identifiable with sufficient data using these models. And when it comes to both physical and mental genes, all of these have immense impact on one's future. Okay, but how would you have the ability to choose from millions rather than several? Well, after many years of painstaking research, Shinya Yamanaka and his team discovered 4 master genes that could turn back the clock and turn any adult cell back into a stem cell. Just as a stem cell could differentiate itself forward in developmental time into a skin, blood, liver, heart, or any other of the 200 types of human cells, these Yamanaka factors could revert any skin, blood, liver, or other type of cell back into the equivalent of an embryonic stem cell. He called these induced pluripotent stem cells, or iPSCs. Yamanaka deconstructed the cell and showed how the biological clock could tick backwards. Yamanaka and Gurdon won the 2012 Nobel Prize because their discoveries have the potential to revolutionize much of biology, including how we humans create eggs.
Through the activation of Yamanaka factors, we can produce, for example, stem cells from skin cells. This means that we do not necessarily need to sacrifice embryos to conduct stem cell research, but we can make them ourselves. And this finding resulted in Yamanaka winning the Nobel Prize in Physiology of Medicine in 2012.
In 2012, Japanese cell biologists Katsuhiko Hayashi and Mitsunori Saito announced they had used the Yamanaka factors to reprogram adult mouse skin cells in a dish into iPS cells. They then added more chemicals to turn these stem cells into egg and sperm progenitor cells, the precursors of egg and sperm. After they placed the same artificial cells into mouse ovaries, the cells matured into eggs. Furthermore, when they put induced sperm precursors into mouse testes, these cells matured into sperm. These induced eggs and sperm were used for mouse IVF, resulting in perfectly healthy baby mice. The average woman who has her eggs extracted yields about 15 eggs for potential fertilization, but induced stem cell technology could multiply that number in a very big way. That 100 milliliters of blood your assistant took during your meeting contains around 100 million peripheral blood mononuclear cells, or PBMCs. blood cells with a cell nucleus. Each of these PBMCs, or any type of adult cell for the matter, can be transformed by Yamanaka factors into induced stem cells. Then, using the process Hayashi and Saito developed, each of these millions of stem cells could be turned into egg precursor cells and ultimately into eggs. So now you have hundreds or even thousands of millions of eggs. The father sperm cells already numbered in the hundreds of millions. But even if the father sperm is not first available, or if he is infertile, the same process could be used to generate sperm from iPS cells. And now instead of around 15 fertilized eggs, you have thousands. Then the lab can use advanced AI tools to machine sort the fertilized eggs to identify those with optimal shapes and biologies, the technological version of what embryologists do manually in fertility clinics today. The next step would be to grow these fertilized eggs for 5 to 7 days until each is about 100 cells, and then extract 5 or so cells from each blastocyst and sequence stem. And so now you understand the technology will be here for choosing a genetically ideal offspring. What do you think the future will look like once these offspring of the wealthy people who could afford the process finally grow up? A bunch of high IQ, tall Chads, and beautiful smart Stacys. These offspring will not only be born with ideal environments, considering their parents could afford this, but with ideal genetics in every possible aspect. The future holds inequality beyond your comprehension, and it extends far beyond income inequality. Perhaps you can integrate yourself into this future though. Even if you are not the most attractive and struggle to find a partner, you would be surprised to know what money can do for you. And with that, I will conclude by saying that you should be very motivated to make as much money as possible within the next decade. You may have the ability to pay for your future offspring to be a part of the haves, rather than the have-nots, whether your genetics are mostly ideal or not. Of course, I'm talking to the large amount of black-pilled folks who watch this channel. In other words, it's not over. Perhaps it never began, but you have the ability to begin now. Begin using your time more productively, make more money, and strive for an ideal future not just for you, but perhaps for your future offspring as well. I'd say I'm about as black-pilled as you could get, and by that I mean I'm a strict believer in the selfish gene principle and evolution. But I'm also a stoic, and I do not see any benefit in living hopelessly. So, while I try to provide the truth to you guys, I also try to provide some realistic hope for what you may have previously saw as a hopeless future. Before I conclude today, I did want to briefly mention a bit where I have been the past 4 months of no uploads. This channel is just a side project. During my main time, I run an online group called Endurance, that of which focuses on providing information, software, and other resources to help resellers make money online. I've been very busy with that, along with my bot, Gargantua AIO, which is a bot for resellers to purchase limited products automatically. That, along with my final year of school, but I'm finally finished now and now full-time on business, which should allow me more time for this channel. With that said, I will leave links to my group and my bot in the description below if you happen to be interested and looking for a new side hustle or entrepreneurial endeavor. Other than that, have a fantastic rest of your day, stay curious, and stay skeptical.
I think one of the biggest mistakes people generally make, and I'm guilty of it too, is wishful thinking. You know, like you want something to be true even if it isn't true. And so you ignore the things that, you ignore the real truth because of what you want to be true.